Hello, I'm Davis Binger, and let's talk about the two-path test. We will work on problem 5 of the 13.3 handout. Recall that the two-path test is used to show that a limit of a multivariable function doesn't exist. You approach the point in question from two different lines, from two different paths, and if you approach on these paths and you get different values, then the limit doesn't exist. So here we have a specific limit we're looking at. The limit is xy goes to 0, 0 of x to the fourth minus y to the fourth divided by x to the fourth plus y to the fourth. And we're asked to use the two-path test to show that the limit doesn't exist. Now, in this setting, it's possible to pick many different choices of paths. I've picked two. You could pick two different ones and come up with a equally valid answer. So I'm going to first consider the path y equals x. Observe that on this path you have in the numerator x to the fourth minus x to the fourth. Thus the numerator is always 0, and along this path, if you take your limit, the limit of the function, which is constantly 0, is 0. As you approach 0 is 0. So along this path, the limit is 0. Now we pick a second path. I've picked y equals 2x. You could pick a second path, maybe the path y equals 0. But I've gone with this one. Now you go ahead and you replace y with 2x in your expression, and then you take your limit as x goes to 0. So after replacing y with 2x, our rational function simplifies to negative 15x to the fourth divided by 17x to the fourth. These x to the fourths cancel, and along this path our limit is negative 15 over 17. Negative 15 over 17 and 0 are different, obviously. Thus, based off of the two paths test, the limit doesn't exist. In other words, we approached along two different paths, we came to different values, thus the limit doesn't exist. Alright, that's all. Thank you for watching, and you can reach me for a follow-up by leaving a comment below or emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.